Okay, today we're going to do volume of prisms and cylinders. The measure of the amount of space that a three-dimensional figure encloses is the volume of the figure. Volume is measured in units such as cubic feet, cubic yards, or cubic meters. 1 cubic unit is the volume of a cube that measures 1 unit on each edge. So, if this is a foot by a foot by a foot, it's 1 cubic foot. What's interesting is to note that a lot of people don't understand that within a cubic yard is 3 feet by 3 feet by 3 feet. What's 3 times 3 times 3? That's where they get 27 of those cubic feet are in 1 cubic yard. So there's a lot more than you might think in there. It's not just 3 times 3, that's just the how many cubes are in one part of that figure. So you see how there's 9 cubes on this side? And there's 3 layers. Or you can do the layers this way, where you look at area of the base, which would be 3 times 3 times the height, how many stacks of cubes there are. That's what volume is. So if a prism has a volume of V cubic units, the height of H units, and each base has an area of V square units, then the volume is area of the base times the height. The big B stands for area of the base. Now, we're going to have to use our area formulas for the shape of whatever the base happens to be. So again, that we had just filled this in. Big B is area of the base. All right, the base of a prism is the shape it's named for, not necessarily the one on the bottom of the sketch, okay? The height of a prism is the distance between the base, one base to the other. I need to cross that out, okay? Okay, so for this particular figure, the base is the bottom, which we'll just look at it as how it's sitting because they're all rectangular. So this would be your base. The area of that would be 7 times 3. And then you would multiply that times the height. So it's real simple for a box. A box, you just multiply the 3 dimensions. So this is going to be 21 times 4. Area of the base is 21 times the height, 4, which would be a volume of 84 cubic centimeters. You're doing centimeter times centimeter times centimeter. So that's how we get cubic centimeters. Find the volume of the prism if the area of each base is 6.3 square feet. Now it's already given us the area of the base. We didn't have to calculate that one. Some of them we will have to calculate what the area of the trapezoid is. That one has is a trapezoidal prism. This is the base and the height. The base on the top is the same as the base on the bottom. So the volume for this is the area of the base, which they told us, big B, is 6.3. And then we're going to multiply that times 3.5. Okay, you already calculated that. Thank you. 6.3. What was it? Times 3.5? Sometimes I've got to remember those numbers I was looking at a minute ago. Yeah, 22.05. Let's just leave it at that since it ends instead of rounding. And then we'll write 22.05 cubic feet. All right, next. Isn't this what I just did? I don't know why that was repeated there. All right, example 3. Now, a lot of kids have trouble with identifying this particular solid. Yes, it is. Okay, its triangles are the bases. And it has 2 bases. This is a triangular prism. Each base is a triangle. So area of a base is base times height divided by 2. And I know that sometimes seems to get a little confusing that we interchange the word base within the formula versus being the area of the base. We're trying to remember that the base is a triangle of that prism, okay, and its formula for finding the area of a triangle is base times height divided by 2. So we're going to do the base area, which will be, this will be our base is 4 on the triangle, our height is 3. So we're going to do 4 times 3 divided by 2 to get the area of that base. That's 12 divided by 2, which is 6 square centimeters. Now that we have that, we'll find our volume. Now, between the bases is the length of 11. That would be the height of the prism. So for the formula, we take volume equals our area of our base was 6 times the 11 height of the prism, or the length or distance between the bases. And that gives us 66 cubic centimeters. And here you can see it again, another way to look at it. 6 square centimeters times 11 centimeters. That's where I'm getting the cubic centimeters. Centimeters squared times centimeters would be centimeters cubed. Okay. Now we're going to look at, well, this is continuation. We'll do cylinders on this page, but first we're going to look at Cavalari's principle. If two solids have the same height and the same cross-section area at every level, then they have the same volume. So all it's saying is that even though this is tilted, you're going to do the problem the same as you would as if it was standing straight up, okay? But the height may be labeled on the exterior. The volume of a cylinder, since the cylinder has a circular base, its base area will be the area of a circle, of course. And that is where the pi r squared comes from, because we've studied the area of a circle to be pi r squared. And then we're going to multiply that times the height of the cylinder, which could be on the edge or could be in the center. It's basically the same formula, it's just now we have a circular base. This base has a radius of 3. So we're going to pop that in and we're going to put in 4 for the height. So the volume for this one's going to be pi times 3 squared times 4. And kids usually find these pretty easy. They just grab their calculator and start typing. Pi times 3 squared times 4. Okay, so I've got 100, thank you, Nathan, 113.1 to the nearest 10th. And that'll be in cubic centimeters. Example 5, this is an oblique cylinder. It's tilted, sort of like the Leaning Tower of Pisa. Where you would measure its height would be on the exterior. How tall it is out here. But we got to figure out the height. And it says, use the Pythagorean theorem to find the height of the cylinder. I am going to draw that separately over here. The eighth we're finding is here. 5 inches is at the bottom. And then the hypotenuse of that is the 13. They're pointing to that side right there. Okay, so we use our Pythagorean theorem, which says leg squared plus leg squared equals hypotenuse squared. So I've got 8 squared plus 5 squared equals 13 squared. 5 squared is 25, 13 squared is 169. When I subtract 25, I get 144. Subtract 25 from both sides. Then you take the square root of 144, which is 12. So the height's 12 inches. Okay, do you see why? Oh, okay. Do not assume any of the special right triangle properties unless you know it's for sure got 30, 60, 90 angles. They got to give you some angles, okay? So if it doesn't give you any angle measures to lead you to using the special right triangles, you're going to use Pythagorean theorem. Okay, what's the radius of this thing? Okay, how'd you know it was 4? Yep, the diameter's 8, so the radius is 4. Okay, so it's 4 inches. All right, now we're ready to do the volume. The volume will be pi times radius squared times the height of 12. All right, so we have a larger number, 603 point, we'll go to the nearest tenth, 0.2. And that'll be in cubic inches. Or inches cubed is how you write it, so I know that's how you say it to yourself. Anybody still need this? Wait a second. No. Okay, find the volume. Now our cylinder is sitting more like a roll of toilet paper. Nothing. Okay, it's got a radius of 6, and the height is the 7. Oops, I kind of wrote over that. All right, so this volume is about, we do pi times 6 squared times 7. That's 791.7 cubic inches. They still do it the same way, except your cylinder's laying sideways. Oh, you don't have that blank? Oh, does it? Oh, you're right. I think you're right. But if it didn't give me that, I think I did put that in the wrong blank, didn't I? Thanks. I was wondering why there wasn't a, yeah, see, I was wondering why there wasn't one of those volume blanks there. So you have the 603.2 in this blank right here? All right, so just make sure, because we're trying to follow our ISN together. You have 603.2 there? Okay, so the volume for this one we'll put here. And we'll use just cubic units since we don't have one given to us. And now I forgot what it was. I guess I can look at my calculator. 791.7. Thanks. And it would be cubic units, and I could just use a U. That's interesting. No one said anything about that first hour. Yeah, catch things, yeah. We are done with the ISM for today. Yeah. Now we're gonna pop over. Ooh. This was first hour. 1 second. I'm gonna save my first hour. Well, I guess I have too many of those open. Hold on 1 second. Sorry, I'm taking too long to get started here. Take a little singing break there. Okay, volume of prisms and cylinders. This is the packet. Again, this is just a recap of what we already put in our ISN. About 1 cubic foot is how many cubic yards? 27 of them. Now, you do have a blank for here. Remember that big B means area of the base. Oh, I need a pen, not a... And H, of course, is the height. Find the volume of each prism. The boxes are probably the easiest because all you do is multiply the 3 dimensions. The bottom or base area would be the 8 times 8 if you wanted to think about it that way. So regardless, we're just going to multiply the 3 dimensions. So I've got 64 for the area of my base times 8, or you can just go ahead and multiply them all at once. What was it? 512? Yeah. Cubic feet. All right, now this one, the second one here, is got a base that is a triangle. Okay, we're going to find the area of that. No, it's not a pyramid because it's not. It looks like a tent, doesn't it? Or a roof of a house. That's a good analogy. The base area is the area of a triangle. So you have to remember that formula is base times height divided by 2, where this would be little b and the height would be the 1.5. So we need to do 3 times 1.5 divided by 2. We're not using it yet. No, I'm doing the base area first. And then we'll multiply by the length between the bases, which is the 4. Okay? Guess I should have done that different color. Anyway, what is 3 times 1.5 divided by 2? Yep, so let's not round that off, okay? That's 2.25. And now we'll do volume is 2.25 times the height, which is the distance between the bases, and that's 4. 2.25 times 4 would be 9 cubic centimeters. Everybody got the 2.25, no problem about where we went with that. I don't want you to round that when you're within the problem, unless it's something really long, okay? All right, let's do another one. Now we're getting to a special right triangle. This is half a roof. How's that? But it is a 30, 60, 90 right triangle here. Guys, we have probably done this pattern, I don't know, 100 times. Maybe you want to remind yourself of what's on the wall. We've got it on. Oops, I think I better change my pen. Highlighter's a little awkward. If that's 30 and this is 60, 90, the long short leg is n, the long hypotenuse is twice the short leg, 2n, and the long leg is n times the square root of 3. We've got a 30, and this hypotenuse is 12. That base has the same length there as this one. So if that's 12, half of 12 goes somewhere, and it goes across from the 30 on the short leg. So this would be 6. And this would be 6 times the square root of 3. Okay, now I drew it this way because that's what's on the wall, or on your formula sheet. You have to be able to apply it as if this was turned. Okay, it's turned over. All right, so now we got to find the area of the triangle. Okay, so the base area is base times height divided by 2, area of a triangle. Its base is the 6 root 3, and its height is the 6. So we're going to use, area of your base will be 6 root 3 times 6 divided by 2. Careful how you type this. This is why I feel like the students who sit there and press the buttons while I'm doing the problems are verifying that they are typing it in correctly and that getting it right. It's often the people who don't practice typing it then when they take a quiz or test, they type it in wrong. So that's why I'm hoping you'll practice typing this, because this one's real easy for you to make a mistake. You got what? 12.7. So let's see what I get. 6 root 3. Now, if your calculator's like this one and you have a flashing arrow here, you've got to get out of there before you hit times 6. Then you can hit divided by 2. It's 31.2, guys. Who's getting 31.2? Because I heard some answers that weren't 31.2. All All right, try it again, please. So you pay attention. It's only as good as how you type it in. Are you what? Okay, I think you're dividing by 2 twice. Well, no, that wouldn't make sense for this either. Okay, there's another way to avoid the problem by doing 6 root 3, hitting enter, then hitting times 6, and oopsie, and then hitting divide by 2. 31.2. All right, now that's the area of your base. Now we're ready to do the volume. Area of the base, 31.2 times the height. What's the height? It's the, okay, no, we already used that. The height of the prism is the distance between the bases. So that's 15. Okay, I'm just going to leave what I have on here. If you do 31.2 times 15, you're going to get a teeny bit different answer because of rounding. I believe you're getting 468. And if you use what was on your calculator already, you would get 467.7. Yes. I would take the 468 because that's just only because you'd rounded this to 31.2. So either one's fine. And of course, that's in cubic feet. All right, find the volume of the prism. This doesn't matter that it's tilted. This is going to be your height of your prism. Your base is 10 times 15 would be your area of your base, and then we'll multiply by 12. 150 times 12, or you just can multiply those 3 dimensions. Yeah, 1,800 cubic feet. What? This was those easy ones. Multiply the 3. Okay. Next one is, what kind of shape is this? Could somebody tell me the name of this thing? It looks like a gold bar. Yeah, that's a good analogy. What? Trapezoidal prism. It has a trapezoid base. Okay, area of the base is you have to add the bases of the trapezoid and divide by 2, then multiply times the height. So you got to remember that area formula for the trapezoid. Yep, the bases are 2 and 4 on it, so you're going to add those, divide by 2, then multiply by the 1.5. That's going to give you the big base area. Okay, so that's 6 divided by 2, 3 times 1.5, which is 4.5. Did you type this all at once? Okay, then you must have done this. Okay, now let's talk. This is why I ask you to type them in. This is incorrect. What's wrong with the way it's typed? That's correct. You just found your own boo-boo. All right, so if you do 2 plus 4 first, if you're telling it to do that first, then hit divide by 2, that is critical to getting the answer right. This is the correct area of that base, 4.5. Now, the volume is area of the base, 4.5 times the distance between the bases, which is 6. So that'd be 27 cubic centimeters. Okay, cylinders and Cavalier's principle. We already discussed this. Even if it's tilted, it's going to be the same process because the cross sections are still equal. If a cylinder has a volume of V cubic units and a height, there's your volume for your cylinder, pi r squared times the height. Let's get to it. Looks like a ginormous can. Okay, tuna can, right? A big wheel of cheese? Yeah, that would be. Oh, yum. All right, Nathan, since you have a lot to say, let's tell me how to do the problem. What's the radius? All right. It doesn't do a whole lot except get you into the cubic units because you can really just type the pi times 2 squared, but don't forget you really did multiply by that last foot. All right, so we get 12.6 cubic feet. All right, number 7, you just have another skinny slung cylinder. It has a radius of 2 as well, but it's only in centimeters, so it's a whole lot smaller than the other one was in reality. Pi times 2 squared times 18. Okay, so pi times 2 squared times 18. To 26.2 cubic centimeters. What's the matter? No phones. All right, now this cylinder is just like the last one in the sense, well, it's got different dimensions. It's just tilted. It still is done the same way. So the volume for it, it's going to be pi times 1.5 squared times 12. $84.8 cubic feet. Okay, next one. I bet we can do this pretty quick. You guys are getting to be very good at identifying that the radius is not 20, it's 10. And the height is 20. All right, just type away. I'm going to ask somebody for my answer. Brent, you already did it? What'd you get? Okay. I believe he's correct. Are we all getting that? Fabulous. 6,283.2 cubic feet. Thank you very much. All right. Oh, trash can. Here's what I want to know. The volume of the Meyer family's kitchen trash can. It's shaped like a cylinder, so it has a height of 18 inches and a base diameter of 12, which means its radius is 6 inches. What's the volume of the trash can? All right, let's find out how much garbage these guys can throw away in their can. Volume is pi times 6 squared times 18. How many cubic inches of trash can the Meyer family dispose of? Although they're going to have to take it out, right? Oh, let's see, where's that? 6, was it 6 squared, and it was 18 for the height. That's a short can, but it's 2,035.8 cubic inches. Now, if you think about that, 18 inches is only 1.5 feet tall. That's not a very tall trash can, is it? Most of us have kitchen garbage cans that are probably 3 feet tall, right? Maybe 2.5, 3. All right, your assignment is what follows. I'd like you to get going on it. You got some time to work on things. But I thought maybe we'd do one problem together that I got asked by my class first hour that was really interesting. So let's go to number, you're going to ask me about it probably anyway. So let's do number 13 together. Now this is really surprising to me, what we're going to find out here. It says Mr. Gutierrez purchased a cylindrical aquarium for his office. The aquarium has a height of 25.5 inches and a radius of 21 inches. So it's some tank. You make a couple ovals and then you connect the sides. I know mine's not that pretty. Oh well. Its radius is 21 and its height's 25.5. Now I didn't make this to scale clearly. Bless you. Okay, so I'm going to find the volume of the aquarium in cubic inches. So that's going to be pi times 21 squared times the height 25.5. We're going to get a pretty big number here. I did it on accident. I'll have to fix that. Oh no, it won't be right. So I'm going to hit second enter, and I'm going to go back and change that E to pi. And then hit enter. All right, so 35,328.8. Yeah, cubic inches. That's the volume of it in cubic inches. Okay, the next line says a cubic foot is 12 by 12 by 12, or 12 times 12 times 12, or how many cubic inches is that, guys? What's 12 times 12 times 12? Please pay attention to this problem, because this is like a really nice application problem. Isn't it 1728? All right, now, why did I do that? Because I want to get the aquarium into cubic feet for a minute. So I'm going to take the volume of the aquarium is how many cubic feet. So what would I do with this ginormous number and this? And I don't think I'm going to, okay, I want to know how, this is in cubic inches, this is in cubic inches. So I'm going to divide them so I can get how many cubic feet. I'm converting to cubic feet. Okay, so that's going to give me cubic feet. What is 35? So I'm going to just grab my calculator and I'm going to hit divided by 1728. .44. Okay, I'm going to round to 2 places. So I've got 20.44 cubic feet of volume in this tank. There are 7.48 gallons in a cubic foot. So every one of those cubic feet is 7.48 gallons. Let's figure out how many gallons of water the aquarium holds. So what are we going to do with that number? Yes, you're correct. Thank you. We're going to multiply times 7.48. So I've got 20.44 times 7.48. 152.89. Now, I'd probably round that. Let's just go 152.9 gallons. Actually, it's about 153 gallons, okay? We're doing approximately. We've been rounding throughout the problem. So you've got to put in about 153 gallons in that tank. Now, that would fill it to the tippy top, which probably isn't a good idea. Your little fish might just jump out of there. But anyway, if a cubic foot of water weighs 62.4 pounds, 1 cubic foot of water weighs 62.4 pounds. What is the weight of the water in the aquarium? Okay, 1 cubic foot. Where's our cubic feet answer? Right here. Okay, you with me? There's 20.44 cubic feet of water in it. A cubic foot of water weighs 62.4 pounds. Let's find out how much that aquarium weighs with water in it. We're going to multiply the number of cubic feet times the weight of the cubic foot of water. 20.44 times, how much did that water weigh? It is. That's what I'm going to talk to you about briefly. 1,275.5 pounds. Now, is that important to know how much your aquarium's going to weigh? Yeah. Back in the day, we had water beds. I know they're still out there, but when I was in college, I had a water bed. And there were certain apartments that wouldn't let you put your water bed in their apartment if you had a second story. Why? Because they're super, super heavy. And that can be structural issue. So they're extremely heavy. I got to tell you, you can't move one without emptying it. You can't move it at all. It's very, very, very heavy. So just think, that's not that big of a tank. And by the way, I Googled these numbers to make sure they were accurate, and they actually are accurate. Because in first hour we were going, what? It's that heavy? So we went to, well, let's just do Google. So I did, I checked it out. And I said, why isn't it typing there? Because it's stupid tabs there. Why is it? It's not being happy. What is wrong with this thing? Oh, it's spinning. Anyway. What does a gallon, well, I don't want a gallon. Let's do, all right, gallon of water. Did we have 3.78? Oh, no, it was in kilograms. We had a liquid gallon of water weighs 8.34 pounds. Is that on our paper? Did we have pounds? That's right, pounds on there? Yeah. All right, then what was the last one? What does a cubic foot of water weigh? No, I'm just going to see that we were accurate. It's 7.48 gallons, and maybe we had that on there. Okay, I just thought that was interesting. Have a nice day.